Today we'll be talking about lesson 2.3 on reflections. So, a reflection is another kind of transformation. So, a reflection or a flip is a transformation in which a figure is reflected in a line called the line of reflection. A reflection creates a mirror image of the original figure. So, what we need to think about is a lot of times in elementary school, we do reflection projects where we will draw or paint on one side of the paper, fold it in half, open it back up, and see what that item will then look like. That line creates the line of symmetry, and both sides are going to be identical. So, when we flip or reflect an image across the line of reflection, we are going to get a mirror image of that original figure. So it's going to look the same way. So if we were to flip the red figure over, would the blue figure be the reflection? So let's think about this. The base of this red figure is closest to the line. So when we flip or fold it over the line of reflection, the base of the blue figure would be closest to the line. We can see that this is not the case. So this is not a reflection. In fact, they simply slid or translated the red pentagon to the blue pentagon. Not a reflection. This is a translation. So remember, translations were from lesson 2.2. Those are also known as slides. So when we look at number 2, and we would fold the red figure over to the blue, so across that line of reflection, we see that this corner would look like this. So we can see that that's not what the blue image looks like. Again, this was a simple translation. So no, this is a translation. They slid that figure over. So now as we look at number 3, if we would fold this trapezoid across the line of reflection, we can see the base is closest, and we have the non-parallel sides, and then the parallel side at the top. So this is a mirror image. So this is a reflection. It was reflected across this line of reflection. Now, to reflect a figure in the x-axis, take the opposite of the y-coordinate. To reflect a figure in the y-axis, take the opposite of the x-coordinate. In a reflection, the original figure and its image are congruent. So basically what we need to know about this is that we can flip items across the x-axis, or we can flip items across the y-axis. And we need to know that no matter which way we flip or reflect the item, that they are going to be congruent. Now remember from lesson 1, congruent means the same size and same shape. For example 4, it says the vertices of a rectangle are A, -4, -3, B, -4, -1, C, -1, -1, and D, -1, -3. Then it's going to want us to use some reflections. So the first thing that I'm going to do is I'm going to plot these vertices of this rectangle in my coordinate plane. So go ahead and take a minute to do that right now. Now that I've plotted my vertices of the rectangle and drawn my rectangle here in the coordinate plane, I can start with my steps A through C. So A says draw the figure and its reflection in the x-axis. So when we are reflecting in the x-axis, it tells us to reflect it across the x-axis. So we're going to flip or reflect it up. So here, we're going to start here. I would recommend starting closest to the axis line. So B is one spot away. So I'm going to make one spot away from that axis, B prime. Remember, it's the new placement of the original image. So again, C is one spot away, so C prime will go here. Now, A is at -4 and 1, 2, 3 spots away. So -4, 1, 2, 3 will be A prime. And then D was at -1, -3, so 3 spots away. So starting at -1, 1, 2, 3 across that x-axis, this will be D prime. So this rectangle satisfies part A. It is the reflection in the x-axis. Now, starting back with the original image, reflect it in the y-axis. So reflecting it in the y-axis is going to reflect it across that y-axis line. So again, starting closest to the axis line, C is 1 away. So this we're going to call C double prime because it's the second new image. D is at -3 and 1 spot away. So this will be D double prime. B is 4 spots away. So 1, 2, 3, 4. This will be B double prime. And A is at -3 and 4 spots away. So here I will have A double prime. Now I can connect my vertices to make my rectangle. So this image satisfies part B, reflecting across the y-axis. Part C says, are the images from part A and part B congruent? So are they the same size? It appears that they are the same size. We can see that each of these rectangles has an area of 6 units. So they are the same size. Are they the same shape? We can see that they are all rectangles. So yes, they are congruent. And we know that they are the congruent because they are the same size and same shape. We now have seen from lesson 2 that when we translate or slide an image, and from lesson 3 when we reflect or mirror an image, that they are going to be congruent. We're not changing the size of the shape, we're just changing their position.